Welcome again. I thought I'd wake you up today with my bright colors. But anyway, this video is about adding and subtracting rational expressions, which sounds like it should be easier than multiplying and dividing rational expressions, but in actuality, it's harder. It's harder because in order to do it, you need to have a common denominator. So I'm going to compare doing an addition problem with fractions over here without polynomials, and then compare over here a subtraction problem using polynomials. So the first one that I'm going to show you is when we have like denominators. That's much easier than when we have unlike denominators and have to get a common denominator. So I'm going to start out with here. So we have tenths as denominators. So what we need to do is just add the numerators and keep the denominators the same. So for instance, if we have 4 oranges and 5 oranges, we have 9 oranges. The oranges stay the same. They don't change into something else. So if we have 3 tenths and we add 5 tenths to it, we still have tenths. So our answer would be 8 tenths because we're adding the 3 plus 5. Now, always when we get a fraction of the answer, always, we need to reduce that fraction. So we notice that these have a 2 in common. So we can divide these both by 2 or reduce them by 2, and we would get 4/5, and that would be our final answer. Now, I'm going to go over here. This is a much more difficult problem. First of all, it's a subtraction problem, and that's a place where a lot of people can make mistakes. But one of the things we have right now is we have the x minus 1 as a common denominator. So what I like to do is just make it a common denominator right away and put the whole thing over x minus 1. So all I need to do then is add the numerators. Now this minus sign is tricky. So this stays the same. So it's going to be 3x squared plus 2x. And this minus sign doesn't just subtract the 10x. It subtracts this whole thing. So what I like to do is sort of like we did with I like to distribute that negative sign right away so I don't miss it. So I'm going to do plus negative 10x and then plus 5. So it'd be minus 10x plus 5. Or because remembering to distribute that negative to everything in that numerator is really, really important and really, really easy to forget. So as I said over here, we need to then simplify this. So this is going to be 3x squared minus 8x plus 5 over x minus 1. So this, we have to see if it can factor to see if we can reduce this. So we're going to do our x factoring with the coefficient in front. So we go a times c, 3 times 5, which is 15. And we want multiply to 15, add to negative 8, and that would be negative 5 and negative 3. So then we're going to have to factor that using this information. So we have this x minus 1 on the bottom. Now one hint, a lot of times these problems are engineered, so you might want to guess that an x minus 1 is going to be in one of these factors. You cannot guarantee that, but if you're really lost, try x minus 1 and see if that works. But we're just going to go ahead and know that, so this first one is going to be 3x squared, and this is going to be plus 5, and these are going to be minus 5 and minus 3. So I like to start at the beginning, so the common factor between 3 and 3 is 3, so this is 3x. If this is going to be 3x squared, this is going to be an x. If this is going to be negative 5, so this would have to be a negative 5. This has to be a plus 5, this has to be a negative 1, and this works 3 times negative 1 is negative 3. So I'm going to erase all this extra stuff here. And we can double check that this works by foiling it. But now that we have this factored, we see that the x minus 1 and x minus 1 are in common. So we can cancel those out. And so our final answer is just going to be 3x minus 5. So my tips and trick for this one is to take that minus sign and distribute it to every term in that it applies to. Combine all the second one is to write this just with the common denominator right here. There's just less things going on because you know the numerators, once they have a common denominator, are just going to be combined. And then once we get this, we have to factor it to see if it can be reduced. And we factored it and reduced it and got our final answer.